Welcome to module 30 of object oriented analysis and design. We have been discussing about sequence diagrams. So, we will continue that discussion, complete the understanding of the sequence diagram, and we will take a brief look into building the sequence diagram of our LMS exercise. So, in terms of the sequence diagram, we have already looked at the basic concepts, that of a lifeline, which is how does an object exist in the system over time, how it can be created within this diagram, how it can be deleted and how it can exchange messages. And in that context, we have seen various types of messages: synchronous, asynchronous, create, delete and reply messages. And we have seen their classification by response type as well. We will continue in this module to introduce the concept of interaction fragments and look at some more examples. So, this is what we have already seen, that the sequence diagram is a major diagram which depicts the inter-object behavior, and it is a kind of behavioral interaction diagram, and these are the main components. So, this is just to bring you back to the same point. Now, this is one of the examples that we had talked of. So, I am sure you have already revised this. This we had left as an exercise last time. So, this is like a sequence diagram for a place order kind of use case in an online store. So, if we take a closer look this time, we have a person object who is basically initiating this order activity. So, there is a GUI to choose the product. So, naturally the person sends a select message to the GUI for the selection. You can look at here, this is a synchronous message. Once this message has been received, then in turn the GUI will send a message, a product, the product that has been selected, that message to the session manager. The session manager in turn will add it to the try to add it to the shopping cart. So, it is like you have selected the item, now you go and say that add to cart. So, once you have selected, before it can be added to cart, naturally the system needs to check in the session manager in terms of what is the present status of that item, whether the item is available, whether the item has so what is the current price of that item, and so on. So, the session manager sends this message add cart item to the shopping cart, and once the shopping cart gets that. So, we are here, shopping cart has received the add cart item, then the shopping cart has to actually create a new cart item. So, it does a new, because this cart item was not there, it will have to be created and put in the cart. So, of the cart item class, a new cart item is created, and that cart item creation, once this is over, then a reply response message goes back to the shopping cart, who then invokes the add cart item on itself. So, now the cart item object has been created. So, now it needs to be added to the cart. So, it is a self message. Once that has been added, then you calculate the price of the resultant price because of this addition. So, that is also a self message, and the item has been added, it is ready for ordering now. Now, in this way the person can actually add several items to the cart, and once she is ready for a checkout, that is checkout, as you will know, is the process by which we say that the items that are put in the cart, you confirm that you want to buy them, and therefore, are ready to make the payment. So, you send the checkout message to the cart, and in that checkout message to the cart, then the cart in turn has to update the profile of the customer, because it has to check whether you are whether you had earlier orders, whether you have some default payment terms, whether you have already have some credit with the store, and so on. So, it will send a message update profile to the customer instance and get a reply from that. Once that has been updated, then the shopping cart again sends a calculate total price, calc total price message to itself. So, that all items that have been added to the cart, their total price will be computed, and on completion of that, a new message place order is initiated to place the order on the order object. And once that place order execution is over, the order confirmation notification is sent back. Naturally, this is just an overall flow of how the order is placed. Of course, there are several details. For example, there are several failure situations that finally will need to be modeled. For example, when we are trying to add an item, cart item, and calculate price, it is quite possible that actually the product that was selected, that item may not be available to be added to the cart. So, what will happen in that case, we will have to check for that. When we update the profile of the customer here, it is possible that the customer has a profile where this sale order may not be a valid one. Certainly, there is a whole issue of a payment which is not shown here, and it is quite possible that the placement of order may not go through. In that case, we will not have a order confirmation, but we will have a order regret kind of notification. But leaving the aside that, if we just work on the kind of, as we say, the happy paths as to what is likely expected path of flow behavior, then this is a kind of a diagram which show how place order will work. So, our task often in terms of sequence diagram would be to actually think about the total flow of events in the system in terms of the classes, the named entities, and identify what message need to go from which object to what object. So, that in that order, in that sequence, we actually achieve the targeted requirements. Now, let us discuss about the interaction fragments. Interaction fragment is a named element representing the most general interaction unit. So, it is like the main idea of interaction fragment is the sequence diagram as a whole is showing you several different interactions. There is a unit interaction between one class with another as one message is sent, then there is a sequence of messages, sequence of synchronous, asynchronous calls, creation, deletions, all these giving you a total complex picture of interaction. But if we just take a part of it, then that part itself could be something meaningful, and if we see that that part needs to be performed several times in several different places in a sequence diagram or in several different sequence diagrams, then we can actually take those out and kind of make them as a reusable interaction part. So, interaction fragments have the general objective of talking about interactions at different levels, which can be taken out and reused at different places, can be referred at different places, and so on. As such, there is no general notation for interaction fragment. There are different kinds of fragments, and each fragment has some implicit notation of its own. These are the common types of fragments. We will now take a look into what these interaction fragments mean. The first is the interaction fragment of occurrence. The occurrence is an interaction fragment which represents the moment in time or event at the beginning or end of a message, or at the beginning or end of execution. So, if a message is sent from say online bookstore shop to account, then this message has an event at the beginning, it has an event at the end. So, these are the occurrence specifications. Similarly, an execution is happening. So, there is a beginning of the execution and there is an end of the execution. These are called the occurrences. So, those occurrence specifications can be used to particularly associate different conditions, different constraints at those. So, we typically have message occurrence, which relates to the events at the sending and receiving signals. We have execution occurrence, which is in terms of the beginning and end of execution, and we may have a destruction occurrence as well, which relates to whenever the objects are destroyed. So, this is the first kind of interaction fragment that is frequently used in the sequence diagram. The second is the execution fragment. It is often called the activation fragment also. In an interaction, it is an interaction fragment which represents a period of time in the participant's lifeline when it is actually executing. So, it is executing a unit behavior or action, sending signal to another participant or waiting for reply message from another participant. So, an execution like in here has started based on some message, and then during this execution one part is it is executing. So, that is the one sequence of things that can happen. Besides, it may need to send some signal to some other participant, message to some other participant. If it is synchronous, then it will have to wait for receiving the response on the signal that has been sent. So, we depict these in terms of the execution fragment. So, the execution is typically drawn out in terms of rectangular boxes. You have been seeing this already. So, you have understood they are filled in gray or they could be just left blank, or alternately we could also use a bigger kind of a rectangle and write the name of the execution. So, here search is an execution fragment. So, this is an execution fragment. So, that basically means that it is kind of an interaction, it is a kind of a small piece of interaction which happens at different times in the sequence diagram and builds up the total sequence of activities, and we designate that with the start occurrence, end occurrence and the actual execution and signaling. Interestingly, it is possible that the interaction fragment of execution could overlap. For example, here we see. So, here you can see one in gray and then another in run. So, basically here the task had started an execution, and within this the task finds that it needs to send a message for getting some service. It so happens that this object, the task object itself, is the provider of the service. So, it sends a message back to itself, and if it sends a message back to itself, then in that same timeline it is actually doing another execution. So, that is what is shown by the overlap. So, when you have overlap, that means basically the same object is having multiple related executions going on at the same time. Here this is a synchronous one. So, when the gray one, the kind of parent one, sends the run message to start the execution of the white part, this part, then naturally the gray part goes on to hold, because this is on a synchronous call. It can also be a different way that it can overlap is if we have some situation of a callback. So, callback is like this. Here you have seen that basically the message is back to itself, but it could also be that the message has been sent from the service to the task, the start message. It is an asynchronous one. So, the start is continuing to execute. Then task in after doing some work in the execution find that it needs some service, it needs some execution to be done by the service itself. So, it sends a callback message. Why is it called callback? Because service had started the task execution and task is referring it back to the service. So, it is kind of a loop finished. Here the loop is on the self, here the loop is through another object. Now, when it does that, since this was asynchronous, the service is still responsive because service is executing, otherwise it would have been on hold and then there would have been nobody to receive this callback message. So, as the callback is received, a new execution overlapped one starts. And since this is synchronous, at this point the execution of the task is on hold, but the execution has fresh execution has started in service overlapped with the earlier execution, and when that is over you send the response back. So, when the response goes back again the task execution continues, and finally, when the task execution ends then you send a reply back. So, there are two situations as we are seeing where overlapped execution specifications are possible, one where there is a self message and one where there is a callback. There are a few other interaction fragments which are used. One is called a state invariant, which basically say if you look at this, there was an execution which started here with this start message, and here we write within curly brace that T is equal to complete. So, which means that there is an attribute T in the task, and we want to say that when this execution will end, then T value of T should be complete. So, that is what is known as a state invariant. So, we are saying that whatever may happen, whatever parameters that this start message could have, but I need that whenever the execution ends, T is equal to complete. So, the state that it reaches must be invariant. So, it could be either written in terms of this kind of a condition statement, or it could be written in terms of actual state values. So, here what we are saying that when this execution ends, then the state must be finished. So, that is the name of a state, it could be any other state also. So, this is known as a kind of state invariant. So, as you can see, these are more like constraints that we can put to ensure that the correct state has been reached or correct situation has been reached in terms of the sequence computation. Finally, there is an interaction fragment called interaction use, which is kind of a subroutine we can say. So, these are if you have defined an interaction somewhere, say the checkout interaction that we just observed, and then we can say that checkout interaction part I can refer here. This ref means that I can actually give a name to that set of interaction, the sequence of messages and the execution and all that, and at a different place I can just refer to it without actually again including all the details of this checkout interaction. We could also, instead of just doing a flat include, we could also actually pass messages, the login and password messages. So, login, assuming that login was earlier specified as an interaction fragment, I can refer to that passing the new parameters here, and I do not need to detail out the whole of what this interaction is. So, when we do that, we say this is an interaction use. So, these are the different kinds of interaction fragments that are commonly available for. So, if you look into this annotated diagram, you can see different places where these interaction fragments can be seen. For example, this is a occurrence specification, there will be an occurrence specification here as well, there will be in terms of the interaction, there is a interaction use which is trying to use the handle error which has been defined supposedly somewhere else. Then there is a separate occurrence specification for destruction. So, you have already understood the different lifeline and message details. You are understanding the interaction fragments also. So, now you are more or less equipped to understand the whole diagram, and for example, this is the execution fragment with the execution specification. There is a start here, there is a end occurrence here, and so on. So, you can go through the, we have been referring to this set of similar diagrams according to as we develop, as we learn more and more concepts in the sequence diagram. So, you can refer to them all here and get a better understanding. I will leave this as an exercise for you to again try to follow the Facebook authentication. You can see a fragmentation being done here. I think there is no other interaction fragment used explicitly here. Of course, you will have the occurrences and executions, I mean all over the place. So, you can study them better. Now, let us move on to using these in terms of our LMS example, in terms of the LMS exercise. Now, certainly we have been, as we have been repeatedly coming through, that we have seen that there are two major named elements, identities in the LMS, the employee and the leave. So, while we want to build the sequence diagram for LMS, these will be the typical objects. So, E1 : employee, which means that of the employee class, E1 is an object instance, E2 is another object instance, L1 is an object instance of leave, and so on and so forth. So, we will have these timeline lifelines on those. In addition, actually what we have not what was not explicit in terms of the specification of the leaf management system, but which is kind of the implementation class that we have to deduce, is if there are so many leave requests reside in the system with the different state information as to whether the leave has just been requested or it has been approved or it has been regretted and so on, then we need some kind of a store to keep these leave information. So, we say we will have an LR, which you can say is a leave record or a leave repository, where all this collection of leave will exist. And so, LR will also provide a major part in terms of the lifeline. So, let us say if we just this is not a very detailed one, as I said that I would like you to detail out each and every diagrams that we are doing for the LMS system, but this is just to show you how to go about things. So, here is the three major lifeline items, E1, anonymous LR and L1. So, how will it start? It starts with the employee sending a request for leave. So, for the request for leave there will have to be several parameters. So, this message will have parameters like start date, end date, the employee's ID, the type of leave that the employee wants. There would be more, but some basic parameters will have to be there. And whom would he send the request? Now, the leave does not exist. So, this request has to go to the common repository store, who is kind of providing the services of managing the leaves. So, this is kind of a managing the leave that we will assume. So, once the LR gets this, then LR knows that this is a, so it has started this execution, LR has started this execution, employee was already in execution. So, we are not showing the earlier parts of how the employee has logged in and authentication and all that, that will be a separate diagram again. But now, LR has received the leave request. So, the LR has to create a leave record. So, we send a create message, here we have marked it as new, and this leave record, this leave object gets created. Now, we know that all kinds of leave are not valid in the system. So, some are valid, some are invalid. So, after creation this leave record sends an self message saying is it valid. So, it invokes a message that is valid. So, which is basically starts an execution to check if the leave is a valid leave or it is not a valid leave. So, it is expected to return some kind of a Boolean value, let us say if valid. So, when this returns, it got this is valid. So, when it returns this, so it is a possibility that if valid may be false, it is a possibility that if valid is true. Certainly, if in case if valid is true, we infer that a leave object has been created with the given parameters and it is a valid leave. So, the response goes back to the LR at this point saying that we have got a correct leave record now. So, once LR gets that, naturally LR will again send a response back, a reply back, that is leave request is added in the system, and based on that again the execution here will proceed. But it is possible that the leave itself is not valid. So, if valid is returned as false. If it is returned as false, then what we will need to do? We will need to do two things. One is we will need to have a delete, send a delete message to itself, because this leave is not a tenable one. So, it has no reason for this to be maintained, and on this return if valid being false, the return will come back to the LR again, and when it comes back to the LR, LR now knows, earlier it knew that it is true, now it knows that the if valid is false, that is the request to create the leave has not been successful, and that is why it got a false message. So, when it gets a false message, then it will again send a response back, reply back to the employee saying that leave request not added in the system, because it was not possible, because the request was not a valid one. So, just that is a very simplistic diagram as yet, but this gives you the basic flavor of the activities that are stated in the specification in terms of what is expected by an employee in terms of the request leave. Now, let us look at the next step. If a leave has been requested, then at certain point of time it will need to be approved. So, we perceive that there is an employee E1 who has to be a lead or a manager, starts an approve leave, sends an approve leave message to the LR, to the leave repository, which has all different parameters. So, there will be further details to that, because you can always question that how does the employee know that such a leave exists. So, we will possibly assume that there is a list which is blindly shown to the leads and managers, and they can pick up any one of them with a leave ID of the leave that is created. It is naturally associated employee ID, start date, end date, all those leave properties. So, once the approved leave is sent to is been received by LR, at this point the LR has to first check that the leave in question actually has an appropriate status, so that it can be approved. So, if a request has come for approval on a leave which is cancelled, that is not certainly acceptable. So, it sends a message to the leave object now to check the leave status, executes, and what is returned is the status of the leave. So, once it gets the status of the leave, naturally there are two possibilities. One is the status is not requested leave, that is it is in some other state, it is cancelled or it is regretted or something. So, if the status is not requested, then LR would immediately return a message, send a response back to employee saying that the leave is not in requested state, and therefore, there is no question of approving it. In the other case, if the status is same as requested, which means that the leave has been created, but yet to be approved or regretted, then it will send a approver message to the leave, which says that we want to the LR as if is telling the leave that I want to initiate the approval process for this particular leave, and I need adequate information for that. So, what is the requirement? We did see in terms of the modeling constraints in the class diagram, which we will use here in the sequence diagram, is approval can be done only by that particular employee to which the leave applicant reports. So, certainly this execution of approval process has to invoke another message, and that message goes to E2, which will. So, E2 is the employee who had requested for the leave. So, leave will send the message there and get back a response from the employee as to who is the reporting person, reporting manager for E2. Now, once that has been received here, the reporting to the information of the reporting person, then the LR will have to check whether this is same as employee E1, because employee E1 has initiated the approval. So, if it is E2's leave that E1 is planning to approve, then E1 needs to be the reporting manager for E2. So, if the reporting manager is same as E1, then certainly the LR proceeds with the approve leave process on the leave L1, and that is possibly approved, or it may not be approved because of other reasons, documentation reasons, duration reasons, and so on, and then that status will return. So, in case the reporting to is not E1, then certainly this part cannot proceed anymore. So, the LR will send a message back that reporting is not equal to E1. So, not entitled to approve the leave. Whereas, if it is successful, then the approval request will go, and at the end of this execution from the leave object we will get the approval status. Then depending on whether the approval status is true, that is the leave can be approved, then you say leave approved, or if the approval status is false, then you say leave not approved. So, based on these conditions, one of these two response messages will be sent back to the employee. So, this is just showing the glimpse of how we can visualize the approve leave dynamics behavior. So, I would request that like this you work on the other use cases and build up the sequence diagram for the cancel leave, regret leave, reject leave, revoke leave, and so on, and that way try to complete the sequence diagram for the LMS. So, in summary, here in this module we have completed the discussion on sequence diagram, having talked of interaction fragments, and then we have taken a quick look into the sequence diagram of the LMS, and for two use cases we have outlined how the sequence diagram will look like.